Hi everyone, my name is Krishnaveni. I am working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management in Department of Chemistry. Today I am going to discuss about one of the important module of the engineering chemistry, module 3, polymeric materials. This is the syllabus which we will cover under the polymeric materials. First of all, we will go through the syllabus, definition, classification of the polymers with examples, types of polymerization, addition, mechanism of free radical addition and condensation polymerization with examples like nylon, 6,6 and terylene. Coming to the next topic, plastics, definition and characteristics of plastics, thermoplastic and thermosettings, and preparation properties and engineering applications of PVC, bakelite, Teflon, fiber reinforced plastics. Next topic is the rubbers, natural rubber and its vulcanization. Elastomers, characteristics, preparation properties and applications of the buna, S-butyl and thiol rubber. Coming to the conducting polymers, characteristics and classification with examples, mechanism of conduction in trans polyester and applications of the conducting polymers. Next, biodegradable polymers, concept and advantages of the polylactic acid and polyvinyl alcohol and their applications. We will go through these topics in our upcoming sessions. Today, first we will learn about what is the definition of the polymers and classification of the polymers. First, introduction. A word polymer is a combination of two Greek words. Poly means many and meros meaning a part of unit. Means poly means many. Many units will combine together and form a one long macromolecule, nothing but the polymer. A polymer is a large molecule of which is formed by repeating linkage of the small molecules called the monomers. The repeating unit of the polymer is called the monomer. Mono means single. Mer means part of a unit. Many monomers will combine and form a polymer. Example, polyethylene. This polyethylene, the polythene bags which we will use in our daily life, it is one of the example of the polymer. Here we can see this is the ethylene molecule. This will undergo the polymerization reaction and it will form the polyethylene. Nothing, we will say polythene. And next, coming to the classification of the polymers. Polymers are classified in a number of ways. Classification based on origin, classification based on monomers or composition of polymers, backbone of the polymer chain, structure, mode of polymerization, molecular forces, thermal responses and tacticity. Okay, based on these, the polymers are classified. We will see one by one the classification. By origin means the polymers are produced by naturally or artificially. Here, natural polymers. Polymers which are isolated from natural materials are called natural polymers. For example, silk, wool, natural rubber, cellulose, starch, proteins. These are the natural polymers. Examples of the natural polymers means we will not prepare them. They will be available in nature. These are the natural polymers. And next is synthetic polymers. Polymers which are isolated from natural materials are called natural polymers. We have already discussed about it. Some more examples are the cotton, silk, wool, rubber. These are the natural polymers. Coming to the synthetic polymers. Polymers synthesized from the low molecular weight compounds are called as the synthetic polymers. Means the polymers which we will prepare, synthesize, are called the synthetic polymers. These are the polyethylene, nylon and terylene. So many examples of the synthetic polymers are there. We will learn about them in the future classes. Okay, this is the polythene. Example of the synthetic polymer. This is the wool, example of the natural polymer. And next, classification based on the monomers, homopolymers and copolymers. What is mean homo? Homo means same type. Okay, the polymer consists of identical monomers is called a homopolymers. Identical means same type of monomers will be present. That is called the homopolymers. Example, polyethylene, PVC, polypropylene and nylon 66. These will contain the similar type of the monomers, one type of monomers. Okay. And next, copolymers. A polymer consists of monomers of different chemical structures are called the copolymers. Okay. These polymers will contain two or more different types of monomers. Okay. Example, nylon 66. Nylon 66 will contain the different type of monomers. Okay. Next, coming to the polymerization. Classification based on the polymerization. Polymerization means formation of large polymer molecules from smaller monomer molecules is called the polymerization. Okay. Polymerization means formation of the large polymer molecules from the smaller monomer molecules is called the polymerization. First, condensation polymerization and addition polymerization. Based on polymerization, the polymers are divided into two types: condensation polymerization and addition polymerization. Condensation polymerization, formation of large polymer molecules with release of byproduct. Okay, some polymers are formed. When they are formed, the byproducts like the water, carbon dioxide is released along with our major product. This is called the condensation polymerization. Means here the byproduct will be released along with our main product. Okay. Next, addition polymerization. Formation of large polymer molecules with no release of byproduct. In addition polymerization reactions, only we will get the products, our polymers. No byproduct will be released. Okay, this is the major difference between the condensation polymerization and the addition polymerization reaction. And next, classification based on the thermal behavior. Thermal behavior means how they will respond to the heat. Okay, they are classified as the thermoplastics polymers and thermosetting polymers. First, we will see the thermoplastic polymers. Thermoplastic polymers, these are easily molded in desired shape by heating and subsequent cooling at room temperature. The main difference between the thermoplastic polymers and the thermosetting polymers is when thermoplastics are heated, they will become soft, and then they are cooled and they can be remolded. They are soft on heat and hard on cooling. They may be linear or branched chain polymers. For example, the thermoplastics when heated, they will become soft, and when they are allowed to cooling, they will become hard. And we can remold the thermoplastics. For example, polyethylene, polyvinyl chloride, polysulfide, polypropylene. These are the examples of the thermoplastics. When they are heated, they will become soft, and then they are cooled. What will happen? They will become hard and they can be remolded. Coming to the thermosetting plastics. This polymer is hard and infusible on heating. What will happen when thermosetting plastics, when heated, they will become in the initial staging soft, and on continuous heating, they will become infusible. They will be degraded. Okay, they are not soft on heating under pressure. They are not remolded. They cannot be remolded. On continuous heating, they will become infusible, degraded, and they cannot be remolded. These are cross-linked polymers and are not reused. Once the thermosettings are degraded, we cannot reuse, remolded. Best example of the thermosetting polymers is the bakelite. Okay, these are the classification based on the thermal response, thermoplastics and thermosettings. Thermoplastics will become soft on heating, hard on cooling, and they can be remolded. Thermosettings will not become soft on heating. On continuous heating, they will be infusible and they cannot be reused. And next, classification based on structure. Based on structure, the polymers are classified into linear polymers, branched chain polymers, and cross-linked polymers. Okay, this we can see the structure. This is the linear polymer chain, this is the branched polymer chain, this is the cross-linked polymer chain, and this is the network polymer chain. Okay, this is the based upon the structure. Based upon the structure, the linear polymer chain will have less strength, when compared to the branched and the cross-linked polymers. These will have, and network polymers, these will have the more strength, high or more strength. Why? They are having the branch structure. These are the linear straight chain structures, and these are cross-linked between the branch structures. That's why they are difficult to break, and they are very hard when compared to the linear polymers. Okay, these are the networked polymers. They will be arranged in zigzag manner. Okay, these are the classification based on the structure: linear, branched, cross-linked, and network polymers. And coming to the classification based on tacticity. What is meant by tacticity? Tacticity simply means deposition of side groups in space. It is a linear polymer chain. They will be side groups arranged on the linear polymer backbone chain. Based on the arrangement of these side groups on the linear backbone chain, the polymers are classified into three types. Okay, the phenomena of arrangement of the side groups on the linear polymer chain is called the tacticity. Okay, here we can see that based on tacticity, they are divided into three types: isotactic, syndiotactic, and atactic. Here we can see this is the linear polymer chain. In isotactic, side groups of the monomers lie on the same side of the chain. Okay, this is the linear polymer chain, and these side groups, here we can say these are represented with the red color balls. These are arranged in the same line. Okay, this is called the isotactic polymer. Coming to the syndiotactic, side groups of the polymers are arranged in an alternate manner. Okay, here in picture, this is the main branch, and the balls, red color balls, represent the side groups. These are arranged alternately. Here it is in the upward position, here it is downward position. Upward position, downward position means they are arranged alternatively in syndiotatic arrangement. Okay, these are called the syndiotatic polymers. Coming to the atatic polymers. Atatic polymers, the side groups are arranged in irregular or random manner around the main chain. Here you can see the example. This is the main chain polymer. Here the side groups are arranged randomly. Okay, this is called the atactic. Okay, tacticity means the arrangement of the side groups on the main polymer chain in space is called the tacticity. Based on the tacticity, the polymers are classified into isotactic, syndiotatic, atactic. Isotactic means side groups of the monomers lie on the same side of the chain. Syndiotatic means side groups of the polymer are arranged alternatively. Atactic means the side groups of the polymer are arranged randomly. Okay, this is the classification based on the tacticity. Next, degree of polymerization. What is meant by degree of polymerization? Number of repeating units in the polymer chain formed is called the degree of polymerization. Okay, based upon the number of polymers in the polymer chain, the polymers are classified into oligopolymers and high polymers. Coming to the oligopolymers, polymers with low degree of polymerization are known as oligopolymers. Their molecular weight ranges from 500 to 5000. Okay, if a polymer chain consists of the 500 to 5000 molecular weight, they will come under the category of the oligopolymers. Coming to the high polymers, polymers with high degree of polymerization are known as high polymers. Their molecular weight ranges from 10,000 to 2 lakhs. Okay, the polymer chain, it consists of the 10,000 to 2 lakhs of the monomers. Then it will be considered as the high polymers. Okay, this is the classification based on the degree of polymerization. With this, I will end my class for today. I have taken reference by Engineering Chemistry by Rama Devi, Department of Chemistry, JNTH. Thank you.